So let's start with Docker. So Docker is going to be very um, interesting, I could say.
How much session will be there to finish Dockers?
I guess around 4 5 sessions would be needed.
Okay. Any prerequisites like we have to install, download, anything like that?
I'll tell you. First, we'll go through concepts. We'll understand what is Docker and why do we need Docker. And you have worked on .NET. Okay, let me ask with Linda. Linda, which languages, which applications, which you have worked?
I mostly worked with Java.
Java applications. Great,
Yeah.
great, great combination. So which is very interesting. Yeah. Actually, we need a wide range of uh, expertise so that we can bring up all together. So let's go here. So let's understand what is Docker. You would have heard about Docker, right? Have you ever heard about Docker
Yeah, yes.
or something containers, Kubernetes?
Hmm.
At least you would have heard about it.
Yeah, I have heard about Docker containers.
Okay. So how about Linda? What about you? Sorry, Sandra.
I don't have any idea.
Mm-hmm.
One day you just given me an hour session for the Kubernetes. I only have that knowledge. Apart from that, I'm zero here.
Okay. Now, from that knowledge, what is your understanding about Docker? So it's been very long. I hope you don't remember that much, but still, let's try
Yeah, it
to.
was something like 2 weeks before.
Yeah, yeah. So yeah, it's fine. But let's try to, you know, remember what we discussed, or let's try to summarize what is Docker, as you know, as per your understanding. In one line answer, if you say.
So it is to
Mm-hmm.
wrap. Uh, it's like an encapsulation, right?
Yeah, you can say yeah, kind of encapsulation. So see, Docker, it is a containerization tool. Containerization tool. So what is this container? Usually, what is container in general terms?
Um,
It's
it's
like a box.
Box.
a
This is a
storage. Yeah.
This is a container, right?
Hmm.
So let's say this is a container. So what we can do here, if it is a container, if it is a bowl, let's say it's a jar. This container we can fill some water, or you can fill something you can fill, right? In terms of application, when it comes to software industry, what is this container? So before understanding this container, let me give you a quick idea. Whenever you deploy an application, now you have deployed .NET application, you have deployed Java applications. I hope you would have an idea on Spring.
Yeah.
I don't have.
Okay,
Spring, right?
Spring,
It's Springs or Spring? Which
Spring
one?
Boot, Spring Boot.
Yeah, yeah,
I
yeah.
don't have.
Hmm. So for you, you have .NET, right? In .NET,
Yeah.
yeah. So .NET itself is a framework, right?
Yes.
Yeah. So in Java, they have Spring framework.
Okay.
So you use .NET, so where you write C sharp.
Mm-hmm.
They use Spring, they write Java code. Only that is the difference.
Oh,
Yeah.
okay.
So now let's see. So now you okay? Let's go about Java. So Linta is there. I'll come back to .NET as well. So
Yeah, it's okay.
yeah. So this is Java. This is .NET. .NET. Okay. So now let me ask you a question to Linta. So Linta, if you are developing a Java application, okay, what are all the prerequisites that you have to make sure are present to run a Java application? Let's say it's a Spring application. It's a Spring application. So first, Java should be installed,
Yeah.
correct? Java
Yes.
or OpenJDK. We'll call it as OpenJDK. Should be installed, correct?
Yes, yes.
Okay, OpenJDK should be installed. Next, what else? Source code should be there. source code. You have to write the source code, right?
Yeah, yes.
So source code should be there. And dependencies, if you have used any,
Dependencies.
dependencies should be there. Am I correct?
Yeah.
Then what else is needed?
Mm, and we need to set the directory JDK.
Yeah, environment configurations, I would say.
Yeah.
Environment configurations. Okay. What else?
Mm, yeah.
If you have used any plugins, I guess that will come. You can consider dependencies and plugins together.
Yeah, yes.
Yeah. So now, if anybody is going to run this application, this is the requisites. These are required. So they should install Java, source code, dependencies, environment configuration. Let's say Java, it is Java 19 version or something, whatever it is. Java 19 version you are using. Okay.
Mm.
19 version. They should install the same version to run your application. Am I correct?
Yeah, yes.
Yes. So everything you will mention, obviously everything you will mention in the readme file or in the require like properties or in the requirement file. So how we can run this. So now let me get back to Sandra. Sandra, I don't have any idea about .NET. You should tell me. So first, to run the .NET application, so what should be there? What to install? So for Java, we need to install
Visual
Java,
Studio.
Java or OpenJDK,
We need Visual Studio.
VS Code. Yeah, Visual
VS
Studio.
Code and Visual Studio are there.
Yeah.
I use Visual Studio.
Okay, Visual Studio then.
Then if you want to
Source
store
code.
data, we need SQL.
Source
We need
code.
database.
Yeah, source code. First source code. That see you will write right. The source code should be there. For you also dependencies will be there. Am I correct?
Yes.
Dependencies will be there. Then environment configuration same will be there.
What do you mean by environment
Let's say
configuration?
you want to connect with the database. Let's say you want to open some port. You will
Yeah, that would be there. Yeah.
some paths you will set up. That is
Yes.
called as environment configuration. Like say here also, if you want data, you have to DB also needed. You have to set up your DB, database configuration. Here also DB same. Only the tool is different. This one is Java. This one is VS Code. All others are same. I think similar. Right?
Yeah.
Now anybody
Yeah.
who is running Java application, who is running .NET application, they have to make sure they all meet this requirement, right? Now let's say I'll ask question to Linta. Let's say Linta is developing this application on Windows machine or let's say Linux machine, because we have already discussed Linux. So Linux machine. So now tell me, do you think this application works exactly same if I give to others?
You mean you deployed and
Yeah,
giving to others?
yeah, let's say I deploy it into some testing environment, some dev environment. Do you think it works same? Yes, most of the cases it
Yes.
works fine.
Yeah.
But there are chances it might not work exactly same if things are misconfigured here.
Yes. Yeah. The configuration should be same.
Same, exactly same. Even small
Yeah.
changes could lead to application may not behave the
Will
same.
not work.
Yeah,
Yeah.
it might work but not behave the same some cases, right? So
Yes.
your .NET also same case in .NET also, exactly everything should be same, right? Then only it works. Then these applications are platform dependent. Am I correct? Platform dependent, like whenever you develop an application, exact same platform should be created to run this applications. Now when you are running 50 plus microservices, you know about microservices, right? Or do you have any idea about microservice, or you want me to talk about microservices as well?
Yeah. Can you just tell?
Yeah, fine. Let's say there is an application, banking application. You know bank, right? Let's
Yes.
say I have ICICI or whatever it is, bank, Axis Bank or whichever the bank. So banking application. Let's say in a banking application, what and all features would be there? What features will be there? First, one login feature will be there. Am I correct?
Yes.
Yes.
So shall I call this login feature as authentication?
Mm.
Auth
Yes.
feature. Okay. Then there will be balance, bank balance.
Yeah, transactions by
Yeah, let's say
balance.
transactions and bank balance. There will be a section for loans,
Mm.
correct? And
Yes.
there will be sections for what else will be there? Insurance, you can also buy, would be there.
Yeah, credit cards.
Yeah, cards, main cards. Okay, then what else? Etc. features will be there, right?
Mm.
If you write the source code for all of these features in same folder, or it's a single project, let's say you're considering as a single project and you're deploying everything together, there is no differentiation. Auth is also in the same, transactions, cards, insurance, all the features as a single application. This is called as monolithic application. This is called as monolithic. Everything is developed together and deployed together. Means single application.
Okay.
What in
Okay.
case if we do any mistakes in auth? Complete application will go down. Am I correct?
Yes.
What in case transaction is not working or something goes wrong with transaction? Complete application would go down.
Yes.
What
Yes.
in case if it is loan section is not working, complete application would go down because everything is tightly coupled together. Means everything is deployed as a single application. Now this will create inconvenience and it is very difficult to manage in the large applications, like when large applications, banking applications, or it comes to telecommunication field or healthcare, any sector where large applications are there, wherein multiple features are involved, it is very difficult to manage everything together. So what do we do? For this reason, instead of doing everything together, we will do microservices. Means we will consider each and every feature as an individual application. Auth as an individual application. Transaction as an individual application. Loans as an individual application. Cards is an individual application. Insurance is an individual application. Everything is deployed separately on different servers, scaled separately, managed separately by different teams. Then they work together to serve the purpose. Are you understanding?
Yes.
Yes.
So they all do API interactions. So APIs will be there, we will expose the APIs, they communicate through APIs. Let's say now the transaction application went down, all other services are running. Are you understanding?
Yeah.
Because this transaction or all other features are not dependent on transaction, because all are loose coupled. All are what? Loose coupled means they are managed separately, they are deployed in separate servers, they are managed, they are developed separately. Now if something goes in the transaction, the repository is separate, the source code is separate, you can go to transaction source code and you can change, you can do the modifications, you can deploy it. So in large applications there will be 50 plus 100 plus microservices will be there. Take Amazon.com, how many features are there?
Hmm.
Hundreds of features are there. Any banking application, take a any hospital application, hundreds of features are there. So all features are deployed separately, managed separately, developed separately, scaled separately. This is nothing but microservices. Now you have 50 applications, 50 microservices. This is called as a microservice now. It's called as service, microservice. Now for one application you have different small applications each and every application can be developed using different tech stack. Let's say this is .NET and this is Java, this is Node, this is Python, this is Golang. It can be different language, different tech stack, which gives the flexibility. Right? So for this you have to set up .NET, for this you have to set up Java, for this you have to set up Node environment, for this Python, for this Golang. Tell me, when you have 50 plus microservices, how do you manage all of this configuration, installation, scaling? Don't you think it is difficult?
Yeah, it will be.
Yes.
It is difficult. Now, developers, being a developer, you are a .NET developer, you will develop your application and you will give it. So now production team who is taking care of deploying it, they have to make sure all the prerequisites are installed, everything is configured, all the prerequisites are satisfied, then only this application will run as you expected. Correct? And you developed Java application, they should make sure all the prerequisites are configured, installed, and everything is done, then only this application runs. So how difficult task it is when multiple people are working together, 50 plus microservices, sometimes 100 plus microservices, 100 plus microservices for one application. Now Amazon company itself, they have multiple products, am I correct? Amazon.com is there, AWS is there, Kindle is there, like that they have multiple applications, right? Now multiple products, thousands of microservices, different teams, how difficult it is to manage? Obviously difficult, right?
Yeah.
So now here, how we are going to solve this using Docker and Kubernetes. Let's come to Docker. So what Docker is going to do, Docker is going to pack this application as a single package. So what it's going to do, it's going to pack this into single package. You see, I'm going to pack all the microservices as a different containers. So now all are packed as containers. This is one container, this is one container, and all are packed as a different containers. Are you understanding?
Yeah.
1, 2, 3, 4, 5. All are packed as a different containers. Then what is this container? What is this container then? This container, it's a portable lightweight package which has everything to run an application. What everything? Source code, dependencies, configurations, and what else need? What else need? Installations, whatever installation is, everything is packed. Now you no need to install Java separately, you no need to download the source code separately, you no need to install the dependencies separately, you no need to do configurations manually. Everything is already configured. Let's say you want to make noodles. You know noodles? You eat
Yeah.
noodles, right? If you want to make noodles, how do you make it? How do you make noodles? How do
We have to uncover the noodles packet. We have to boil the water. We have to
Hold
pour
on,
the
hold on.
noodles into the water. Yeah.
Hold on. Let's say you are in 90s. You're not in today's era where you get noodles packet. You're in 90s. How do you make noodles?
We have to make the dough, and from that we have to do the noodles.
Yeah. So now you are doing this task. Till date, whatever you guys are doing, directly you are deploying an application. That is nothing but you are creating all the then you are creating everything manually. You are preparing and you are doing it. So now Docker is new era wherein you will get noodles packet. So in noodles packet you get noodles, masala, and everything needed to make noodles. Correct?
Yeah.
Just put some water and put the noodles, boil it, your noodles are ready. Correct?
Mm.
Yes.
That is nothing but Docker. So Docker will simplify your application. It will package your application in a very simple way so that you have to run very few commands. Let's say to one command, your application is up. No need to install, no need to configure, no need to download the source code, no need to do any configurations. Only thing is just get this package and run one command. Your application is up. How easy it is now. Easy to whom? Easy to those guys who are deploying this, and easy to developers as well. See, every time you no need to do all the installations and stuffs. Let's say you want to test your application, pack it, just run it. You want to distribute this application. Let's say you want to give this application to your colleague who is working with you. Just give this Docker package, this container to him. Easy. Now your colleague, no need to install anything, no need to do all the prerequisite configuration setup, nothing. Take this Docker container, run it. That's how Docker container works. So what we are doing, what are the containers? Containers are lightweight packages which has everything to run an application. The installation, the source code, the OS, the dependencies, configuration, each and everything to run an application is packed as a package. This package is called as a container. What is called as container.
Containers.
And you can run multiple containers on the same server. Now where do you run your .NET application? You will log into some server, maybe your Windows server. Where do you host your Windows servers? WinSAP or AWS, Azure? You have no idea about it?
Mm-mm.
Do you have any idea where do you have your servers? Where do you deploy your applications in your organizations?
In Azure.
In Azure? Okay, so how about
Azure service.
how about Linta?
Yeah, in AWS.
In AWS. So
Yes.
now let's say in AWS, so if it is AWS, then so if it is AWS, then it is an EC2 instance. So it's an EC2 instance. If it is Azure, then it is what? VM, virtual machine, right? So let's say you created an EC2 instance. Do you have any idea about EC2 instance? Have you ever created?
Yeah, yes.
Okay, so yeah, we created VM also. Do you remember?
Yes, I remember.
So
Yeah.
now in the same VM, I can run multiple containers. I can run multiple containers on the same VM. That means you are running microservices, multiple microservices on the same machine, separately, individual. So this is completely different application. This is completely different. This is completely different. This is completely different. Or if you want, you can deploy this into different virtual machines as well. So we'll talk about it later. When it comes to Kubernetes, we'll talk about it. Now I just wanted to understand what is the container concept and why do we need it, and why container. Now tell me why container. I explained the scenario. Now give me some reasons why should I go for container, why not the traditional method.
If containers are easy, means our work is bit more comfortable. We no need to install separate packages. We don't want to get the platform and anything. We just have a
We just
container, and that will take care of everything that needs to run an application.
You're right. So containers are portable. This is the reason. Containers are easy to create and manage. Containers are lightweight. Containers are faster compared to traditional method. So these are the major reasons why we go for containers. Now
Portable means, what do you mean by portable here?
portable in the sense it runs on any machine irrespective of operating system, irrespective of machine, whether it is a server, whether it is a laptop, whether it is a desktop, whether it is a any machine, only the prerequisite is container engine should be there.
Okay.
So now
Mm.
anybody can make noodles, only the prerequisite is there. They should know how to cook. They should have gas stove. Correct?
Do we only use containers for microservices? Don't we use it for the monolithic
Everything.
ones?
Yeah, you can use for everything. You can use for monolithic, you can use for microservice, you can use for multi-tier, you can use for everything.
Okay.
Mm. Okay.
Anything. Everything. Any application you can pack. So you pack it portable. Means this portable package, it runs on any machine irrespective of operating system, irrespective of environment, irrespective of configurations. No need to worry about it. Only only thing which is needed, only thing that you have to take care of is container engine should be there. What is this container engine? Or container engine or container runtime, I would say. Container engine, or I would say runtime. Container runtime should be there. What is this runtime? What is Java runtime, or let's say .NET runtime? Runtime in the sense that platform to run, right? Platform
Yeah.
to run. So same container engine, container runtime should be there. That is nothing but your Docker. So what it is? Docker. So Docker is a containerization tool. So it gives you the platform where you can create containers, create and run containers, create and run containers using Docker. Create and run containers using Docker. Create and run containers. Now just to understand the concept of Docker, I started from there. I started from application, .NET, Java, microservices and problems. Then we came here. Now you got the complete understanding of why Docker is needed, because understanding why it is, what it is very important than just doing it. I can just teach you, oh, this is Docker, you do Docker file, this is how you have to do it, this is what the command you have to do it. You will do it, but you will not understand why you are doing it, right? This is very important. So now I hope you understand why you are doing it, why we need Docker, why should I go for it. Now you are working in an organization. Let's say tomorrow you go as a technical architect, or you go as some team lead or senior team lead. You got a responsibility to handle a project, right? You can suggest your team which is the best practice, which is the easy method. How can we make the process faster? Since Docker is there, it is easy and it is faster to deploy the application, right?
I have a question. Like for if our applications are deploying in AWS, we are not using then Docker, right? Just directly deploying in AWS, right?
Yeah, you are
Okay.
directly deploying it on servers, but uh, like we are not sure whether servers are already running a Docker engines and you guys are deploying it into. Did you ever create Docker file to your application? If not,
Uh,
then it is
no,
not.
no, I'm not sure.
In your project check, is there any file called Docker file? Then it's not. You're not running as a container. You're directly deploying. Means you will generate a jar file, right?
Mm.
So jar is directly deployed. Is it the scenario?
Yeah, yes.
Then it is manual deployment. They are not
Okay.
using Docker.
Okay, okay.
Will not
So in
generate.
AWS itself, we can do this kind of like direct deployment, and using Dockers, we can do both in AWS.
You can do.
Mm.
In Azure also you can do.
Okay.
Everything is possible. You can do direct deployment. You can deploy using Docker. You can deploy. So now container we create using Docker. Then later Kubernetes comes into picture. This guy is just for creating containers. But who will manage these
Okay.
containers? When in large applications we run hundred thousands of containers at the same time. Let's say Amazon.com. or let's say
Mm.
your some music application, hundred thousands, millions of containers will be running. Now if you open ChatGPT, so millions of users are requesting,
Mm.
right? So how to
Mm.
serve millions of users? To serve millions of users, you need hundreds of servers, thousand, maybe thousands of containers to run together. So how do you scale to such large scale? That is where DevOps comes into picture. That is where all we are learning this container concept, Kubernetes concept, scaling, uptime, and all of these concepts. So yeah, so I hope tomorrow, before coming to the session, now this is theory, just a theory. Tomorrow I will explain you Docker architecture, and we are going to containerize the application. So I want one .NET application from yeah, from Sandra. You create one .NET
Mhm.
application. So you are going to containerize your .NET application. Linta, you create your Java application. You are going to containerize
Mm.
your Java application. Small application.
Okay.
Maybe are you familiar with Maven?
Yeah.
Okay, then create Maven. Sandra, you
Okay.
have to take care. .NET, which framework you will use, what you will use, what are the prerequisite components and all. Uh, you have to take care of it, and just bring your source
Like,
code.
do you just want a .NET application, or do I want to install, deploy that in IA server?
No, no, no.
What should I do?
Just the source code I want.
Okay.
Just the source
Mm.
code I want. No need to install. So then I will containerize that as a Docker file. Then we will deploy using Docker. Then same Java application, you just write the source code, a simple application, just hello world also fine.
Okay.
Okay, simple application you created. Maybe you can use Maven better. Like let's keep it as a production grade application only, but content is very simple.
Mm.
Same architecture we will use. Content you keep it hello world or some simple to do application or whatever application. If you don't have, I have the project I can give you, but better you can create your own project so that you get a confident, oh, I deployed my application which I created using Docker. So from your side you bring a .NET, from your side you bring a Java, from my side I'll bring Python application,
Okay.
right? Because being a DevOps engineer, you should be able, being a DevOps engineer or any engineer who is working as a DevOps or who is working on cloud, you should be able to deploy any application irrespective of technology.
Okay.
You should
Okay.
be able to deploy it. For Java, .NET major technologies, Python major technology. If we can complete these three, you will get more confidence. Oh, okay, I know how to deploy Python application. I know how to deploy Java application. I know how to deploy .NET application. For you, at least, like, whatever, like you are working on Java, you just focus on Java only. Just focus on .NET only. But little bit exposure you will get. You can just you will get to see how Java works. You will get to see how Python works. You will get to see how .NET works. So this gives you the confidence and idea how things works around. Okay, tomorrow this
Okay.
is your task, and tomorrow I want you to install Docker desktop. So both are using Mac or Windows.
Mm.
I'm
Windows.
using Windows.
Windows.
Okay, so then Docker desktop you have to install. How to install Docker desktop? Go to browser, type Docker desktop here. Docker desktop install. Desktop install. Hold on for a second. Yeah, so go to this browser and install Docker desktop install on Windows. You just can scroll down and here you go. Yeah, where is that? Oh, and Docker desktop by Docker. Yes, here it is. So you see, you go here, then you install this. So install Windows
Okay.
64, whatever it is. Before that, make sure WSL is installed. You know what is WSL, right? Hold on.
Yeah, the hypervisor you told us to install, right? WSL.
Yes. So before installing Docker, make sure WSL is installed. How to install WSL? Go to command prompt and in type, go to command prompt or PowerShell as an administrator. Type WSL space hyphen hyphen install. It will install the WSL. Once WSL is installed, install this package and run this package. After installing, it will give you an exe file. After exe, you have to run that exe. Then if you open, this kind of application should open, this kind of interface should open.
Okay.
Is my interface
Okay.
visible? Yeah, so this type of interface should open. So then I'll take it forward from here. Installation, complete the installation. Once the installation is done, we'll complete from here. We'll continue from here. Yeah. Okay, then with that I'll end it here. So make sure you install the things and you revise the concepts, and we are going to do it. So you got 2 tasks. So maybe for creating this application you might have another day of time, because tomorrow I'm going to show you how basic containers, you can create some basic containers and all. So for this you can take one more day for creating the application. Tomorrow
No.
the mandatory thing we want this one, Docker desktop.
Hmm.
Okay, so install this and come. For this you can take one more day, not a problem.
Okay.
Yeah. So fine, then we will end the session here and we'll meet tomorrow. Tomorrow same time, right?
Yeah, 10 o'clock, right? 10 p.m.
Yeah, 10 p.m. Okay.
Okay.
Sure, that works. Okay then, see you tomorrow guys.
Bye.
Yeah.
Yeah,
Bye.
thank you. Bye. Have a good day.